Okay, we're going to go ahead and get started again. If everybody will make sure their phones are muted, and if they're going through the computer, make sure that is muted, just so we have good sound quality. I'd appreciate it. Again, I'm Mike Hammond with Climate Master, and I'll be your presenter today here for the webinar on Tranquility digital products. And I want to thank everybody for joining. And if you're on our earlier morning one, I appreciate you coming back here. We again apologize for our technical difficulties with our first webinar. We hope this second one will go a whole lot better. So again, please make sure if you're just joining that you are muted on your phone, just so that everybody can hear clearly. All right, thank you. We're going to go ahead and get going here. First part of my presentation today is going to be more of an overview of our product, kind of going over some of the different revision levels. I know with a lot of the changes we've had of recent time here, there might be some confusion with some of the revision levels and such, so hopefully we're going to clarify a little bit of that for you here this morning. And then right after that section, then we're going to get a little deeper on the technical side of the DXM2 communicated controls, as well as the VFlow options as far as the internal pump or the modulating valve, and also how we commission these heat pumps. So appreciate everybody joining, and that's kind of our agenda here for today. The first slide I've got here kind of talks about our 2011 lineup. Again, with our these are all our non-communicating products. Again, the TT was our 2-stage, and it's now a 30 up to a 30 EER. Now looking here, we're going to kind of go down the line here. Our introduced this past year the TE version, and it was an upgrade, if you will, of our TT. It has the iGate controls as well as the VFlow options. And again, also on the 38 model, it has a micro-channel air coil. Again, if you could out there, make sure you're muted. I'd sure appreciate that. The TT version now is a Rev B or C, and the Rev B was the change in the new K5 compressor in it. That also enhanced the efficiency of it. That's how we were able to bring it up to a 30 EER. And then on the 3-ton version, we have a micro-channel air coil.
Okay. Can you hold for just a second?
Yeah,
please?
just a second here.
Somebody's saying they can't hear you. I'll go to. We're gonna take everyone off of mute. Can you take somebody off mute and confirm?
So we're going to verify the audio again here. Again, I apologize.
We had some trouble with audio at the last webinar, so we're just making sure that it works. And we just got a couple of questions from people saying that they couldn't hear.
That was before it got started.
Okay. Continue.
Okay. All right, we're back. Again, apologize, folks. Okay. Kind of going on down the line here, our other packaged digital unit is the TZ, and we have a current Rev B on it on 3 of our sizes, the 024, 36, and 060. Those 3 sizes have different coaxes now in them to slightly enhance their efficiency as well as better pressure drop through those units. So that was the Rev B on the TZ models. And then they packaged single stage, no changes there, the TS Rev A. Going into the splits, again, we've just introduced the new TEP and TES. Those are the new communicating indoor and outdoor splits with the iGate controls as well as the VFlow on the water side. And we'll get into a little more details of those here in just a bit. And then the TTP and TTS is the non-communicating splits that, again, we've had for some time now. Again, the TTP being the outdoor and the TTS being the indoor split. Now in our air handlers, again, the TAH Rev A is the non-communicating air handler, again, still available. And then the TAH Rev B is the new communicating air handler in order to be able to work properly with the TEP and the TES. And again, we'll go into more details and how things can be interchanged with one another here in a few other slides coming up. So again, the Rev B, it has a new control board called the AXM board that will communicate with the DXM2 board that's in the TEP and the TES. It also can be connected to a non-communicating split if that was to happen out in the field. And then we have a TAC, again, our case coil for the dual fuel options. Our water to waters, again, no change, TMW and the THW. Now, looking at our Tranquility Digital products here, again, some of the top two selling points, again, is quick installation, easy to troubleshoot. Again, with the iGate controls, a lot of information can be had right from the thermostat or the service tool. And with our VFlow, again, quick installation, no external flow controller if you opt for the variable speed pump option, or even in an open loop application with the built-in modulating valve, none of that time required to plumb in an external valve, flow regulator. All that will be controlled now through the modulating valve inside the heat pump on an open loop type application. Looking at our package 30, looking at some of the highlights of it. Again, our capacities are 2-ton through a 6-ton. This unit is offered in upflow, a counterflow, as well as a horizontal. It comes in the same cabinet size as the TT27. So if you've been used to installing the TT27 as far as sizes of your return air opening, heights, that still stays the same here with the new TE. Again, this is the TE model. Again, but it comes with all the good bells and whistles with the VFlow, which again is either the built-in variable speed pump or the modulating valves. And then the iGate controls, again, the DXM2 control board that we can use a communicating thermostat with. Currently, there is no climate dry option in this model. In the future, there will be a climate dry option, but at this time there is not. And then our Tranquility 22, which is our TZ model. This was our first model that we introduced our new communicating control, our DXM2, as well as our VFlow options, the built-in variable speed pump and the modulating valve. This unit is a much compact cabinet, again, packaged unit, offered in 2-ton through 5-ton, and we also have a couple half-ton increments. And again, this is also a 2-stage Ultratech scroll compressor inside. There is no downflow configuration, so this is either an upflow or a horizontal. That is the only configuration in this series. And also no climate dry. Again, this cabinet is so compact, there will be no climate dry option in this particular model. Our new digital splits, which are, again, is our TES for our indoor split and our TEP on our outdoor split. The TES is essentially the compressor section of the TE packaged unit as far as the layout, control box, that kind of thing. So again, service was in mind when if you need to work on one of these. So the refrigerant connections right up to the front of the heat pump in the upper left-hand corner. So again, making it easy to make your refrigerant line connections to your line set. And again, this is offered in a 2-ton through a 5-ton and even ton increments. Again, with our iGate DXM2 control and our VFlow water flow, whether it be the modulating valve or the variable speed pump. Our air handler, again, to be matched up with that is, again, the TAH Rev B with the new AXM control board that communicates with the DXM2. But again, you also have the option of non-communication. So if you were putting this, you had one of the new air handlers with a older TTS, you can still make that connection and have the unit work properly. Again, capacities, again, in the air handler to match our splits, 2, 3, 4, and 5-ton. The airflow, again, is adjusted through the, we're going to get more into this in the technical portion of this presentation, but through the service tool or the thermostat. And again, we can adjust in 25 CFM increments. Again, with our digital controls, again, some of the big features, again, are the VFlow, built-in variable water flow, our iGate communicating controls, again, that allow us to have, just 4 wires between the thermostat and the unit. Oops. And again, on our splits, all that's carried over into the split as well. Again, things like the high and low refrigerant service ports are easy, accessible right behind the front access door. Again, once we verify that water side, if we have to get on that refrigerant side, we got our ports right there making it easy to do. Obviously on our splits, we're going to be making those connections so that we can properly charge the system, and we got those ports readily accessible. And again, only on our splits, this makes it a real nice feature versus what we had before. Only a 4-wire connection between the split section and the air handler section. So again, very nice, especially in a retrofit application where you may not have enough control wires between the two without pulling new wire. Again, the iGate controls, again, it's a 2-way communication between a lot of the devices you can see here in this sketch here. I'm going to pull up a little highlighter here as we go through a few things. And you can see again, our thermostat, our service tools, 2-way communicating between the DXM2 and that device. 2-way communication to our ECM blower motor. For doing a split, again, 2-way communication to the AXM board and the air handler. 2-way communication to our pump. Single-way communicating to our valve in order to get the valve positioned properly. So again, a lot of communication going on between our components. Again, with the communicating control, again, we can configure, monitor, and diagnose. Again, we're going to get into a lot deeper on these points in the technical section, so I'm going to save a lot of that until we get to there. With the VFlow, again, with that variable speed pump, one of the biggest advantages of that variable speed pump is pump watt savings. And you can see here in this graph here, especially as we get to our larger systems, where we're typically into more pumps. We're typically maybe putting a 2-pump flow controller on a 4 or 5-ton system, and in some cases it may be 2 Grundfos 116 pumps. Well, those pumps, again, they run anytime the heat pump's running. Those pumps are pulling 448 watts of power. To get the same flow rate through our variable speed pump, we're talking 141 watts. So again, significant pump watt savings can be had, again, with the VFlow variable speed pump option. Let's look a little bit now here at the breakdown in the model number nomenclature, and one of the big points I want to point out is the water circuit options. And in these digital units, the only option is either a modulating valve or a built-in variable speed pump. Now, the modulating valve comes in 2 forms, either a closed loop version or an open loop version. And the two should never be interchanged. The valves are drastically different between the two. And for instance, if you were to put an open loop version on a closed loop application, and to get your closed loop type of flow rates that we're usually trying to achieve, there is significant pressure drop through that valve. And it'll probably drive you to adding another pump on the system needlessly, just because of having the wrong unit for that application. So the two should never be interchanged from one another. So if you're doing open loop, you order the open loop version of the modulating valve. If you're doing closed loop and you want to use a modulating valve with an external flow controller or doing central pumping on that type of an application, then use the closed loop version of the modulating valve. And then again, the internal variable speed pump is only to be installed on a closed loop pressurized closed loop system. So again, if you're doing a non-pressurized system, you must use the motorized modulating valve for closed loop. and then use an external non-pressurized system. Looking at our splits, the TES, again, you can get, again, the same three options as the two packaged heat pumps. Again, the internal variable speed pump or the two options of the modulating valve that I just discussed.
He wants intelligence.
On the TEP, the only option is the internal flow controller, because again, this is an outdoor split unit that's to be installed outdoors of the home, and it's only designed to be on a closed loop system, not to be open loop. So the only option is the built-in variable speed pump with the built-in three-way flush valves for a closed loop application. Now we'll look at some system comparison here. First one we're looking at is our split systems. I apologize, the verbiage up there says package, but this is actually our splits. And we're looking at our indoor communicating versus non-communicating, and our outdoor communicating versus non-communicating. Essentially, efficiencies have stayed the same, very close to one another. As far as you can see some of the other bullets there, again, the big ones, again, are obviously our internal VFlow options and our iGate communicating controls, again, being that DXM2. Warranties are all the same between those products. Again, here's looking at a few the other features. Again, every one of our residential units all qualify, again, for the 30% federal tax credits. So again, everything we build residentially, not an issue there. All right, let's look at these splits a little bit closer. Let's look at the wiring here, and this nice pictorial view of what's going on here. And you can see our TES model there with the DXM2 control board. Again, only a 4-wire connection to the TAH Rev B with the AXM board in it. So we're communicating between the air handler and the compressor section. And then again, we can connect our ATC communicating thermostat to that air handler. Again, only a 4-wire connection, and we got communication all the way through. Now, if you were, for whatever reason, wanting to use a non-communicating stat, Honeywell, whatever your flavor is, you can also use, you can still do communication between the air handler and the compressor section, the TES, and then use non-communication between that AXM board and your thermostat. So that's showing a single thermostat here. You could also do, duct zoning the same way through the conventional wire inputs. And then the option 2 there shows a non-communicating air handler, again showing we can also do conventional inputs from the DXM2 board to our conventional air handler, and then on through to the conventional thermostat. It'd be a similar setup there if we were doing a dual fuel with a gas furnace with our split. Now, another scenario here again would be our new air handler with the AXM board in it and an older TTS with the CXM board. So again, we can go back and forth, if you will, between the revision levels of the air handler here. So again, we can still use non-communication between our AXM board and our TTS, and from the AXM to a non-communicating thermostat. I want to also now talk a little bit about, again, our website. Hopefully most of you have been out there to the climatemaster.com and then the dealer section of the website, or dealer website. Again, a lot of information out there. And under training, for instance, under training, we've got a lot of different training videos out there. And again, we got a lot of information on these new DXM2 controls, going through the fault codes, how to set these units up, how to flush them, all kinds of information out there on the website. Most of these are a YouTube format. So again, a lot of that can be viewed from your smartphone when you're out in the job site. We got the videos even broke down into individual fault codes. Next up, right after this slide, we're going to get into the more technical side, and kind of along with that, I want to point out we have, with the DXM2 control board, there is two versions. There's the N02 and the N05, and we're moving more towards the N05, and the N05 has a slightly bigger microprocessor on it. But a couple other things that visually you can tell the difference between these two boards is that the N05 will have two jumpers, and we're going to talk about the AO2 jumper here in the technical section, which is right here underneath where I've got the highlighter. And then we now also have an AO1 jumper. Currently we're not using that, but in some future applications we're probably going to be using that AO2 jumper there. And along with that, then there's two additional terminal points here for the AO1 jumper. So if you get one of these boards maybe for a replacement and you look over here at the N02, again, it does not have that jumper, don't be alarmed. If you don't need that, it's just on there, it's not a problem. And again, the current version for both boards, again, will be the 1.2. In the case of the N05, there's also a version 1.3. We've been putting, to distinguish that just from a quick glance to the board, what version you have, we've got colored dots on the center of the microprocessor here. You can see the two yellow dots. That'll indicate currently that you have the most up-to-date version of this control board. All right, let's get a little deeper now into the DXM2 and then into some of our VFlow options. First, I want to talk about some of our connection points on the DXM2 control board. And if you're using a communicating thermostat, you can see over here to the left-hand side where we would make our connection from our ATC thermostat. Down over here on the bottom side of the control board, this is where we can hook up a conventional thermostat. So if we wanted to use a Honeywell or whatever brand thermostat, we'd have that option to wire in right there. Let's talk about these dip switches just a little bit. On bank 3 is our smaller of the three dip switch banks. And the very first dip switch, the one on the far left-hand side as you face this board, is dip switch number 1. And that should always be in the on position. And that is so that we have communication to the communicating thermostat. If that's moved to the off position, your communicating thermostat will not communicate with the DXM2 board. So that must always be in the on position. On the board, a couple other items. The test mode in this board, now a button. You press the button. And there's also a jumper on the board. The JW3 jumper is for our LT1 freeze protection sensor between the TXV and the coax, formerly called FT1 in some of the previous products. It's now called LT1. And if we're doing a closed loop and we've got antifreeze in the loop and we need to have a minimum of 15 degrees freeze protection, then we can cut the jumper. And again, if you're doing a closed loop and your entering water temperature is going to drop below about 45 degrees, you're going to need to put antifreeze in that loop and cut that jumper. Otherwise, you're going to have nuisance trip outs on LT1. So that's the jumper that does get cut. I always recommend you have the power off to the board when you cut that jumper, so that there's no chance you're going to short something else out on the board in that process. Back to our dip switches, bank 3. The remaining 3 dip switches, again, we just talked about dip switch 1, but the remaining dip switches are functions for the hot water generator. Number 4 turns the pump on and off. Number 3 allows you to select between a cutoff point of 125 degrees or up to 150. If you do 150, though, you better have an anti-scald valve installed in the system. And then number 2 is a test mode for the hot water generator pump. And what that does, as long as the unit is powered and the compressor contactor is pulled in, we can run the pump, and it'll run for 5 minutes regardless of what the thermistor readings are that are controlling the hot water generator. And that will allow you, especially on a startup, to make sure that we've got all the air out of the system, we've properly bled the piping between the heat pump and our hot water tank. so that, you know, we know we're not going to be burning up that little Taco circulating pump inside there. So that's a nice option. Now, the other two large dip switch banks, and they're labeled bank 1 and 2, S1, S2. Under most residential situations, all these dip switches should remain in the on position. Please, if you think you need to make an adjustment here, consult the DXM2 IOM that comes with every one of these products, are also on that website you can download. And they go into greater definition of what each one does. Make sure you understand before you make a move there. For instance, talk about a couple of them. Over here on bank number 1, dip switch number 2. If I was to move that into the off position, that is for a commercial option where we have a larger unit with 2 compressors. And then what will happen is, if I move that on a TE or a TZ, I get a call, nothing's going to happen until I get a second stage call, and then it's going to bring on the compressor. So again, that's not something we want to have happen with our residential pieces of equipment that only have 1 compressor. So that dip switch should always remain on in those products. Number 7 is for a boiler cooling tower application. If I move that to the off position, once that loop temperature reaches 50 degrees, we're going to go into emergency heat. And if we're using, say in that application, we're using a non-communicating thermostat, there's going to be possibly no indication on the stat that we're in emergency heat until that homeowner gets that electric bill and is going to be very frustrated with you. So again, we want to make sure under most residential applications, these are always in the on position. If you think you need to make an adjustment, make sure you thoroughly understand what that dip switch does. Again, looking in the DXM2 installation manual. Now, bank 2 over here is for if we're going to configure some of our accessories. So again, these you might make an adjustment depending upon what you want to do. And for instance, if we want to control a humidifier with the ATC communicating thermostat, we can move dip switch 4 and 5 to the off position, and now we have a dry contact over here on the side where I've got this yellow line over here for our humidifier. So we can use the transformer and the humidifier, bring in to this terminal strip, and then when the thermostat, the ATC thermostat's calling for humidification, it will then power the solenoid valve for the humidifier and bring on humidification. Now, right below dip switch bank number 2 here, that is that AO2 jumper. So just a few minutes ago when I was talking about these jumpers on the board here, this AO2 jumper is very critical to our VFlow components, whether it be the modulating valve or the variable speed pump. And if it's in the incorrect position, that pump or that valve will not be operating properly, and it's probably going to lead to some lockouts on for you. So it's very important that this jumper be in the correct position. And again, it should leave Climate Master in the right position for you for that model that it's built for. So for instance, there's 1 of 2 positions it can be in, and it's labeled right there on the board on the back side of it. Either the 10-volt position, and that's for the modulating valve, or the PWM position for the variable speed pump. PWM stands for pulse width modulation. So again, this jumper is very important, and if it's in the incorrect spot, it could lead to a lot of frustration until you verify that was in the right spot. Again, it can lead to LT1 lockouts in the heating mode, high pressure lockouts in the cooling mode if it's not in the right spot. So I really stress, if you're having an issue with the pump or the valve not working like it should, one of the very first things that needs to be done is verify this jumper is in the correct spot. Now, with the variable speed pump option, we have a cabinet temperature sensor, and in the package heat pumps, we're using it's just a bimetal switch that is normally closed that we send 24 volts to, and it's powered from R and H over on the P2 connector here that's circled. And again, you can see here in this shot, the bimetal switch is right below the pump, and if the cabinet temperature reaches 125 degrees, it will open, and thereby what it's going to do is actually potentially slow down the pump, depending on where the pump is running. It'll essentially, it's pretty close to 75% pump speed, and that is to protect the pump at those higher ambient temperatures. Now, that being said, in some applications that may not be a problem. You may not even be running at that type of speed. But where this really applies is mainly in the south, where we might be installing these units in an unconditioned space, and again, dealing with the higher temperatures that we see down south in the summer especially. We could be reaching those kind of temperatures in the cabinet. Probably not much of an issue if you're up north and this unit's inside a basement or a crawl space, that kind of mechanical room. Probably not going to be a problem. But if you're down south, might be something to consider. We might want to make sure this is in at least a semi-conditioned attic space. You know, a lot more homes are going to the foam encapsulated attics, things like that, to help prevent this from being an issue. On the split systems, we have an extra thermistor port, over here on the P10 connector that's circled, and we're using the both T4 connect points, and we're actually using a thermistor instead of the bimetal switch. Because again, on the split systems, this port on the package units is actually the leaving air temperature sensor, but in the case of a split, that's actually then being wired to the AXM board up in the TAH air handler. All right, let's talk about the service tool here a little bit. And the service tool is the ACD-U01. I highly recommend that, again, the service tech would have one of these. Again, you must have this or the thermostat in order to do any kind of service or setup or diagnostics on this product. Again, without this or the thermostat, and you're out there on the job, you might as well have handcuffs on. There's not much you can do without one of these tools. But again, I highly recommend the service tool because 9 times out of 10, that thermostat is not that close proximity of the unit. You're either going up and down a flight of stairs or in and out of an attic to get to that thermostat. With the service tool, you can plug it right in front of the heat pump and go through the processes that you need to in order to commission the heat pump or look at any kind of service information. All right, so with that service tool, it comes with a wire whip with 2 Molex plugs on it. And so it makes it an easy connection to the control board. And again, you can plug it in on the fly. Plugs right into the P5 connector, which is right next to where the communicating thermostat would hardwire in. Now, the service tool allows you to change any of the installer setup. It allows you to view any control diagnostics. It allows you to even run the unit in the under control diagnostics in the manual mode. Again, you cannot run the unit with the service tool as the thermostat, saying, put in 70 degrees or something like that. But you can run it in manual mode, giving it specific calls. So we're going to look at some of those screenshots here coming up. Now, the thermostat is the ATC32U01 communicating thermostat. And again, it's only 4-wire connection. So you can see here with the thermostat removed from the subbase. We got R and C for power, and then we got an A and B that's actually our communication going back to and from the thermostat to the DXM2. Now, when you first power up the thermostat, you have to configure the thermostat. And the first screen that comes up is it single stage or multi-stage? Again, with all the products that we've got this control board in so far, everything's multi-stage. So we'll be choosing multi-stage. Sorry about that. The next item that comes up is the thermostat, you want to make it programmable or non-programmable or take advantage of night setbacks. So that can be your option. And then we also need to configure the thermostat, or we're going to have any kind of auxiliary heat. So electric being, again, our internal electric auxiliary heat pack. Multi-fuel, again, on our splits if we're doing a dual fuel application. And then no auxiliary heat in some cases where maybe down in the deep south we don't have any auxiliary heat installed in the heat pump. And then after the next menu after auxiliary heat is how do we want to control that auxiliary heat pack? Do we want it to be able to supplement the heat pump, or do we want it only for emergency heat purposes? So we have that option. Now, after you get done configuring the thermostat, the installer screen will pop up. And what I got circled down at the bottom, it actually will show you the revision level of your DXM2 control board and the thermostat. If you plug in your service tool, you'll see the DXM2 control board version as well as the service tool version. So that can be very handy, especially if you need to call into your distributor for technical help or our technical service department here at Climate Master. Knowing the revision level can help because maybe some of the menus have slightly changed in some of the versions, those kinds of things, so that they can better aid you in helping you with your problem that you might have. All right, the first thing we're going to go into is system configuration. And system configuration, this menu is also in the thermostat as well as the service tool. Now, when you get one of these communicating products from Climate Master, again, they are already configured with factory defaults from the factory. So again, under most cases, you're not going to have to go in here and make any changes here unless, you know, an item like this first one highlighted, airflow, unless we want to make an adjustment to the factory default airflow settings. Now, when you might have to go in and configure one of these boards, well, if you have to change out the control board for whatever reason, you'll have to go in and configure it for what model of heat pump that you have and some other items that we're going to talk about, the blower type, pump setup, modulating valve setup, those kinds of things. We're first going to look here at airflow selection. Under airflow selection, we can look at the current airflow setting for each mode of operation, heating stage 1, heating stage 2, and so forth. We can select one of those and then adjust the airflow in 25 CFM increments within a min and the max for that particular model. So if I'm configured, let's say, for a TZ036, there will be a min and a max for each one of those categories that I can move the airflow within. Now, if you go into the installation manual for a TZ unit, for instance, you can look at a blower table and it will now show the min and the max and then the default. The default will be the factory default setting for that product. The next option beneath airflow is option selection. And under there, there's an item called this motorized valve. This is not, and I emphasize not, to be confused with the modulating valve that's inside the heat pump. This is if you want to, for whatever reason or your application, install an external valve and we're looking for the in switch from that slow opening valve coming back to the board. So the default is this is turned off. You want to leave this off unless you've got that external valve installed. If you turn that on, nothing's going to happen to that heat pump until it sees that in switch feedback from that valve. And if that valve's not there, that's not going to happen. The next item is the compressor anti-short cycle protection time. And the default is 5 minutes. You can't go any lower than 5 minutes. You can go up to 9 minutes. The next item you see here is the LT2 set point. And again, this will not show up under any current product. The only time this will show up that you can make a change to the LT2 set point will be in the future on a water-to-water product when we put the DXM2 communicating controls in our TMWs. Again, because you cannot freeze protect the air. This is for, this is our freeze protection for our air coil. You cannot freeze protect the air. So there is only that one set point, and the LT2 will trip out at 30 degrees on that refrigerant line. Again, if it was a water-to-water product and we actually had antifreeze on the load side, we could then change this set point from where it says water here to where it'll say loop. Again, just emphasizing, again, that top one highlighted there, motorized valve. This is not the modulating valve inside the heat pump if your unit has one of those. This is for an external solenoid valve. And again, most applications, you need to leave this in the off position unless you're installing an external valve. All right, unit configuration. Under unit configuration, this is where you configure it for the heat pump family, whether it's a TE, TZ, TES, and so forth. And then the heat pump size. And again, I want to emphasize this is already done for you at the factory, so you should not have to go in and change here unless you're changing on a control board or you're following up from on a service call that somebody else was out on and maybe made a change here that they shouldn't have. The next item is the blower type. This is where you'll choose, again, ECM motor, PSC motor, or blower type will be none. It'll say none there on the DXM2 if you're doing a split, because on the DXM2 there is no blower attached directly to it. It'll be part of the AXM board in the split system. And then under loop configuration, you'll have your variable speed pump. You'll have variable speed pump in parallel. Again, in variable speed pump in parallel will be if we have, again, multiple units on a common loop. We've got to choose variable speed pumps in parallel because the pumps are in parallel with one another, and we've got to control that pump a little bit different so that, again, it's kind of arm wrestling match between those pumps so that one doesn't lose out and flow stops and then the unit locks out. Also under loop configuration, if your unit has a modulating valve, we have the modulating valve option. And then there is an option there for none. If you choose none, your pump or your valve will not work. So again, that's the only option in these heat pumps, so you're going to have to choose one or the other if you're configuring this unit. Again, the default, if you've got a variable speed pump, will be variable speed pump in single. So again, if you're doing a parallel pumping option, meaning you got that unit with another unit on a common loop, you must choose variable speed pump in parallel. Again, here's just the a big bullet that's part of the installation manual talking about that variable speed pump option. And again, here's just a screenshot showing, again, variable speed pump in parallel if that's our application. Now, the pump or the valve is controlled via delta T. So we're measuring entering water and leaving water, and we're going to control the speed of the pump based on delta T, temperature difference from entering water to leaving water. Now, I'll talk a little more about where you can adjust that here in a moment. You can also control the variable speed pump at a fixed pump speed. But I would caution you in doing this, you really need to fully understand, because now no longer will the pump be ramping up and down. It's going to go to a fixed speed in a particular mode of operation, heating stage 1 and 2, cooling stage 1 and 2. And you really have to understand your loop field, that you've got the right flow rate at that particular pump speed, that it's going to perform the way it needs to perform, as well as your heat pump. So I really caution you in using fixed speed pumping unless you really got your arms around what's going on in your whole system. Whereas delta T, there's some things going on in the background that we adjust the pump for. For instance, we'll get to here in a moment, in the heating mode, if the entering water temperature drops below 40 degrees, we automatically reduce the delta T, increasing the speed of the pump. Now, the pump range. If you choose, again, the default option, the variable speed pump in single, so meaning one unit, one loop, the range of the pump is 15% to 90%. So that's the range of the pump that we operate within. We don't go any lower than 15%. We don't go any higher than 90%. If we choose variable speed pumps in parallel, we minimize how low we let that pump go, and we only go down to 50%, so 50 to 90%. And we react much quicker to any change in what's occurring in the system. Again, because pumps in parallel, it's an arm wrestling match between our different units with their pumps. Now, the range of operation here on delta T. The heating delta T is anywhere from 4 to 12 degrees. The default will be 7. With 7 degrees, under most applications, it'll achieve you in the neighborhood of 2¼ to 3 gallons per minute per ton, which is, again, our ideal flow rate, typically through a closed loop system. Now, there are some things we'll get to in a moment why you might need to make an adjustment there based on fluid type, number of circuits, those kinds of things. The cooling delta T can go anywhere from 9 to 20 degrees. Again, the default will be 10. Again, reasons why we might need to make a change. Again, to maintain the turbulent flow within the loop. Again, on the heating side, especially if we're dealing with propylene glycol in a colder climate. You know, when that loop starts dropping below 40 degrees, that propylene glycol becomes very viscous and harder to pump, and we start lowering our Reynolds number, our turbulent flow through the loop, and it usually requires us driving more flow rate than 3 gallons per minute per ton, depending upon our loop design. So we really need to look at that, and we might need to lower the delta T to help overcome using the propylene glycol. Also, again, if we have extra circuits, you know, if we have more than 1 circuit per ton typically, we're going to need a higher flow rate, because now we take the total flow and we divide it amongst those number of circuits, and the flow rate per circuit is less, and that turbulent flow could fall below, again, our minimum of 2,500 on our Reynolds number. So those are things that we need to look at, and we get a whole lot deeper into that into our loop training module. So again, if I would encourage you to you know, get with your distributor. That's something that we can offer, they can offer for you. Some automatic delta T offsets that are occurring. For instance, in the heating mode, if the entering water temperature, again, is less than 40 degrees, meaning, hey, we're starting to get a cool loop here, we automatically reduce that delta T by 2 degrees. So that factory default of 7 now becomes 5. Again, when you lower the delta T, that speed of that pump goes up. If, on the other hand, if the entering water temperature is greater than 60 degrees, we came just out of summer, we're into early fall, we got a fairly warm loop, we increase that delta T by 2 degrees, slowing the pump down, thereby keeping the compressor in a better operating envelope, more efficient. The other benefit to that, again, in some of those shoulder times, we are actually, with the hot water generator, able to produce hot water when we were not before by slowing that water flow down through that coaxial heat exchanger, keeping that compressor in a better operating envelope, keeping that discharge temperature back up a little bit, where we can actually make some hot water. Now, on the cooling side, we do much the same thing. If our entering water temperature is less than 70, then we increase it by 1 degree, thereby slowing the pump down. If the entering water temperature is greater than 90, hey, we're starting to get a warm loop here, we reduce it by 1 degree, again, speeding the pump up, increasing the turbulent flow, hopefully a little more heat transfer into the ground. Okay, so that was, we covered system configuration here. System configuration, again, this is the thermostat installer settings. That menu is all in the service tool. We're next going to jump down here to service mode. Service mode is all here in the thermostat, as well as the service tool as well. So we're going to look at service mode here next. All right, first thing, whoops, there we go. Under service mode is manual operation, control diagnostics, dip switch configuration, fault history, and clear fault history. Under manual operation, we can obviously, just what it says, we can manually run the unit, we can operate the unit. Control diagnostics, we can look at what's going on in the unit. We can look at all our temperatures from all our thermistors. We can look at control voltage, flow, airflow, and water flow. We'll get talked to here in a moment. We can also, in our dip switch configuration, we can see what our dip switches are actually set to, which can be kind of nice if this unit's in a dark area. It's hard to see sometimes. Fault history, we can actually look at if there's been faults. We can see up to 5 faults in the system. And we can actually look at things that have actually happened at the time of the fault. So we can actually see what all our temperatures were at the actual time of the fault, what all our flow conditions were, airflow, water flow, input outputs, and our configuration, and then possible causes. We can also, you know, if we've had a situation, we've had some faults, we've corrected whatever that situation was, we can actually then clear fault history and start over with a new clean slate. All right, so let's take a look at manual operation. Manual operation, you can give the unit specific calls. So not only can I just turn on Y1, Y2 for second stage compressor operation, I can also go down here to pump speed and actually tell the pump a specific speed I want it to run. So here in a little bit, we're actually going to talk about commissioning these heat pumps. And when we go to commission one of these heat pumps, we recommend now going through manual operation, giving the pump a specific speed, may take 2 or 3 times getting the speed that we want to get the actual water flow that's on our specifications for that unit. So let's say, for instance, we're dealing with the TZ036 and we want to get 9 gallons per minute. We'll keep adjusting the pump speed until we get our 9 gallons per minute. Or if we happen to have a valve, we'll keep adjusting the valve position until we get there. It may take 2 or 3 times. And again, the more you do this, the more it's going to be easier to do. But that's how we recommend. That way you can get the unit as close to what the specifications are as possible. So we're not doing so much interpolation of the data. Because again, real world out there, a lot of times on the non-communicating units, we go to do a pressure drop reading, it's never exactly what the book says. So then we're trying to do some interpolation, and that can create some errors, and sometimes we could be going down the wrong path. Now, on the airflow here, back to manual operation, we can also give it a specific airflow. So again, depending on what our airflow says in our specifications, we can run it up to there, and it's going to run that blower to that speed and stay there during the manual operation. We can give it an O call if we want cooling, bring on the reversing valve, then energize Y1, Y2, and then we got our second stage. And anytime we got a 2-stage product, whenever we go to commission it, we always want first and second stage engaged when we go to commission it. Also remember, anytime we commission the heat pump to do heat of extraction, heat of rejection, we want to make sure that hot water generator is turned off. So remember the dip switches we talked about earlier. Bank number 3, we would turn dip switch 4 to the off position, disabling the hot water generator pump. We can also, from this manual operating screen down here at the very bottom, test mode, we can actually, instead of hitting the button on the board, we can actually toggle it into test mode right here. So 1 of 2 ways we can go into test mode. Now, once we get it running, so we can actually see what our temperatures are, and if we got a variable speed pump, if the pump is running between 50 and 90%, we can actually see GPM. We actually can read our feedback signal from the pump and actually display gallons per minute on the screen. So now we'll have gallons per minute, our entering water and leaving water temperature on the screen. We've got almost everything we need in order to do our heat of extraction, heat of rejection calculation that we're going to do here shortly. Now, in control diagnostics, this first screen is any physical inputs, and it also shows you if your high pressure switch, your loss of charge switch is either open or closed. Obviously, if they are open, we're going to have to correct that first before we do anything. Okay, the next screen under control diagnostics, there's 3 screens, will be our control status temperatures. And this is where then you can see all your temperatures, LT1, LT2, and so forth. I'm not going to read every one of those. Entering water, leaving water. You can see your control voltage. That can be very helpful, if we got a voltage issue going on. You can see your blower RPM and your targeted CFM. The last item says ECM blower static. Currently, we are not calculating static pressure. We will be doing that in a future revision of our control. But right now, it's going to say NA. So don't be alarmed if you get one of these units and it says NA there. Right now, we're not calculating static pressure. Then the third screen is your pump screen. And there you'll see your pump speed and percentage. So again, in manual operation, we would drive that up until we would go into this screen and see the flow rate that we wanted to see. So you can see also your pump watts. Again, that's where this pump really shines, as I mentioned earlier in the presentation. Pump watts are a whole lot lower with these variable speed pumps than your typical single speed pumps that we've used for years out there. The next thing under service mode is our dip switches positions. Now you cannot change the position of the dip switch here electronically, but you can at least see what position they're in, and it gives you a brief description of what that dip switch is. So earlier today, I mentioned again on dip switch bank 1, number 2 is for that dual compressor unit. So again, that should always be in the on position. All these dip switches under most residential applications Number 7 is that boiler cooling tower. Again, we don't typically are not doing that in a residential application, so that should always be in the on position. Oops, apologize there. Dip switch bank 3. Again, there's 4 dip switches on that bank. Number 1 should always be in the on position. That is so our communicating thermostat will communicate with the DXM2 control board. It also shows you on this screen if the JW3 jumper was cut or not. So if it's not cut, it'll say well. If it does get cut, it'll say loop. Next, we have our fault history. And again, we can display up to 5 faults. You see one fault here that's highlighted, LT1 low water temp fault. So we can select it. And then once we select it, we can look at conditions at the time of that fault. So the first thing would be the fault temp conditions, fault flow conditions, I/O conditions, configuration conditions, and then possible causes. So we can look here at all our temperatures at the time of the fault. Here's LT1, 28.1 degrees. Well, if the jumper's not cut, it locks out at 30 degrees, and we're just a little bit under that. Again, it's got to see it for 120 seconds upon initial startup, so it could drive just slightly below that, and it looks like, you know, it's doing what it was supposed to do, just from what we see right here. So again, we can go on down. If this was a real world situation here, we could see, you know, if anything else was out of whack, entering, leaving water, that kind of thing. Control voltage. We can look at our flow conditions. Again, airflow, water flow, pump speed. If you got a valve, it'll show valve position. And then any of our input-output conditions. So over here you can see if you're getting an input from a communicating thermostat, Y1, O and G, and then any safeties if we had a high pressure switch open, our outputs, our fan, our hot water generator, our loop pump. Outputs over here, CC is our compressor contactor, CCH would be our power going up to that rectifier for the Ultratech scroll compressor. RV is the reversing valve. And then our dip switch positions at the time of the fault. This could be helpful, again, if we got somebody maybe playing around with the unit that shouldn't be, maybe made a movement on a dip switch, had it lock out, then oh, they moved it back. This will show at the time of the fault what position those dip switches were in, as well as the jumper, LT1. And then possible causes. So again, this LT1 fault, low water temp in the heating mode, low water flow heating, and so forth. Okay, we're going to skip over that. We're going to continue on here with a few other things before we take some questions. I want to cover here in the next several slides, again, how we commission these heat pumps, because I think it's very, very important. And again, we're going to do this with a service tool or the thermostat. Again, I'm a big fan of the service tool because you can do it right in front of the heat pump as this picture shows here. We've got our wire whip, we plug right in, we can control this right in front of the heat pump. We're not going in and out of wherever the thermostat's located from the unit. All right, so we're going to go into manual operation as I've kind of mentioned before. We're going to start from the bottom up here. And again, the first thing we're going to do to reiterate is we're going to run that pump speed up. So we might, you know, we're going to see GPM between 50 and 90%. So what I'd recommend maybe starting about 65%, go back into control diagnostics, see what your flow rate is, and then start adjusting the percentage from there, kind of get a start point. And then, you know, it might take 2 or 3 times to get to the flow rate that you're looking for, like on that 3-ton heat pump, 9 gallons per minute. Now, if you happen to have to run the pump outside of 50 and 90% and you cannot see GPM on the screen, we'll then have to take a pressure drop reading. Or if you have a modulating valve, you must take a pressure drop reading because you will never see GPM on the screen. Now, to do the pressure drop, we do not use the PT ports that we typically put on the front of these heat pumps. We now have attached to the front right-hand corner post of the heat pump down by the water connections, both a pressure in and a pressure out pressure port that's actually an automotive Schrader port. So just like on your car tire, we recommend get a digital tire pressure gauge and measure pressure in and pressure out, take the difference, and we have to use the chart in the installation manual and convert that to gallons per minute. So similar to what we've done, but we cannot use the PT ports to reiterate. If you have PT ports on the front of the heat pump, that's fine. But if you take a pressure drop there, that pressure drop is not the pressure drop across the coax. And in fact, you'll see a slight pressure increase with the pump, but that pressure difference is actually on the loop side, because now the pump or the valve is inside the heat pump, and that's going to change that reading. So you must use those pressure ports on the front of the heat pump if you need to take those in order to get your gallons per minute. Next bullet up is our CFM. Again, we'll go to our CFM and raise our CFM to what our specifications are for that heat pump to commission it. And then if we want to run it in the cooling mode, we're going to energize O next, and then Y1 and Y2. We're going to get it running for 10 or 15 minutes, and then we'll take our entering water and our leaving water temperatures off of the service tool or the thermostat. Here's just a screenshot of the manual operating screen, again, what you'd actually see. Again, and then we would make those changes as we've talked. Now, in the back of every one of the installation manuals for the digital products, we now have the specification pages for full load operation for the particular model that installation manual is for. For instance, this is a TZ 036 here, the Tranquility 22 model, and I got it highlighted here in yellow or circled in yellow. If we had 30-degree entering water looking over here, skipping on across, we're in the heating mode. We got 3 different GPMs that we can look at, 4.5, 6.8, or 9, that we can commission it to. So again, we're going to run that pump percentage up until I can see 9 gallons per minute on the screen, or if it's outside of that range or I'm doing with a modulating valve, I can go here to WPD, water pressure drop, and under PSI, I'd be looking for a pressure difference of 7.6 PSI with my digital tire pressure gauge using those pressure ports on the front of the heat pump. Next, I look at my CFM. For each water flow, I have 2 airflow specifications, either 920 or 1150 in the case of this 036. So, I pick one of those, I drive my airflow to 1150 CFM in the manual mode, and the blower is going to go to that mode. Next, I got my water flow now. The formula for, again, heat of extraction, heat of rejection, which I'm going to show you here in a moment, is, again, delta T times gallons per minute times a fluid factor. Well, we got our gallons per minute now dialed into 9 gallons per minute. We're going to get our delta T right off the screen because we look right there on the control diagnostics, our entering water and our leaving water, subtract the 2, that's our delta T. The fluid factor is going to be one of 2 numbers, either 500 for water or 485 if it's an antifreeze solution. Multiply those 3 numbers, and we're going to get a calculated heat of extraction. So right here where it says HE, heat of extraction, these are in thousands of BTUs. So our specifications, according to the engineers for this unit, 20.9 in the case of a 1150 CFM, or 20,900 BTUs is how many BTUs we're extracting out of the loop. Now, when we make our calculation, we hope to be within 10% of that number. If we're within 10% of that number, that unit is running just fine. If it's outside of that, then we got a problem that we're going to have to, fix. So that's how we're going to use this data to commission the heat pump. We always do water side analysis first before we ever put gauges on the heat pump. The only exception, of course, is our split systems. We've got to charge them because now we have a field installed line set between the compressor section and the air handler section. Again, here looking at the screen where you can get your entering water, your leaving water temperatures. Again, if we got a variable speed pump running between 50 and 90%, we got our GPM right here. And look at those pump watts. Again, that's where this pump really shines. 70 watts. Holy cow. That is nice and low, isn't it? Again, we got our GPM here, our delta T right off the service tool or the communicating thermostat. Here's that formula I was talking about a moment ago. Again, we got our fluid factor of either 500 for water. If we got an antifreeze solution, we're going to use 485. The formula again for either heat of extraction, heat of rejection is the cooling mode. Again, heat of extraction is the heating mode. Heat of rejection is the cooling mode. Delta T times gallons per minute times fluid factor gives us how many BTUs we're either extracting or rejecting to the earth loop. We then compare that to the specifications that we just looked at. And again, if we're within 10%, that unit is running just fine. There is no need for putting gauges on or doing further service to the heat pump. The heat pump is doing what it needs to do. Now, if we cannot see, again, GPM on that thermostat or the service tool, again, we got to get out that digital tire pressure gauge. We're going to run that pump speed up or down or that valve position up or down until we get the pressure drop on these pressure ports. You see right here, pressure ports on the front of the heat pump using our digital tire pressure gauge. Not the PT ports that are typically here at the water connections. If we use those, those are not the pressure drop across the coaxial heat exchanger. We must use the pressure ports. And again, that's an automotive Schrader port just like that's on your car tire. Again, in the installation manual, there's a pressure drop chart based on entering water temperature and each model what the flow rate is in correspondence to that pressure drop. All right, that completes our webinar here. We're now going to take some questions, and I'm going to have my helper over here, Adam, help me with the questions here. If you will, raise your hand. There's a little section there for you to actually raise your hand. And if you got some questions for us, we'll take them now.
Okay, Mike, B. Voighton asked earlier that he said, you're sending a lot of information through the comm lines. On new construction or where it may be easily done, do you recommend using a shielded cable like a Belden?
Good question. You don't always have to use a shielded cable. It's not always necessary. The biggest thing would be to verify you're not running the wire parallel with high voltage wiring. You know, you need to have a minimum of a 2-inch separation between any kind of a power conductive cable. If you have to run it closer than that, then yes, the shielded cable would be something to look at. Other than that, there's not a problem. That's where it makes it very nice for retrofits, assuming that thermostat wire was not, again, strapped right along a power wire. So good question. Thank you.
Okay, Dennis Klingel has a question. If you have a conventional stat connected, may you also connect a communicating stat for service?
Very good question. Yes, you can. We've had some folks do that. If you're using a conventional thermostat and you want to permanently connect a communicating thermostat, maybe mounted right on the side of the heat pump for service and diagnostics, if you want to do that, you can. But what you must do is leave the communicating thermostat when you don't want to use it for diagnostics or service in the off position. So you need to make sure the communicating thermostat is off, and then you can use it only for service. Now that also what you'll have to do when you want to use the communicating thermostat that's hardwired in for service, you also need, at that time, you have to make sure your conventional thermostat is actually turned off. Otherwise, what it's going to do is it's going to show no communications across the top of the screen. So again, good question, and yes, you can if you wish not to have a service tool.
Carl Weichman asks, when are you going to release communication zoning package with VFlow equipment?
Very good question. The communicating zone system will be coming. It is in development. I don't have any kind of date or time on that, but we will be having a communicating system that will work with our DXM2 controls, both split and package heat pumps. So again, good question. Just don't have a time and date for you at this point.
Brian DeJong asks, do you feel that marginal loops will be more severely impacted with a variable speed pump unit?
It's a good question. That kind of be a case-by-case scenario. I would think it's not going to be any more impacted than with single-speed pumping. You're just still going to have to pay attention to what kind of flow rate is going to be necessary through that that particular loop. You may want to adjust your delta T lower based on what that loop configuration is. So it's kind of a tough question to directly answer because it's a case by case scenario that I would highly recommend that you run through our design tools, being our GeoDesigner. You can run backwards through the GeoDesigner tool in a retrofit application, and then also our pressure drop software has our new units in there so that you can verify where your Reynolds number is as far as turbulent flow. So again, good question. It's just kind of a case-by-case scenario, and if you're running into a problem like that you don't feel real comfortable with, please reach out to your distributor or to our folks here at Climate Master. Thank you.
We have another question from Britt Hightower. He asks, do you have to cut a jumper for ground loops instead of open loop?
Yes, Britt. If you're doing a closed loop with antifreeze in it, and again, if your system is going to run with an entering water temperature below 45 degrees, you're at the point you're going to start tripping out on LT1, our freeze protection for the coax. And if you're doing closed, in that case, it's always a closed loop system if you're running those low temperatures typically. And you're going to need to have a minimum of 15 degrees freeze protection, antifreeze in the system, and then we can cut that JW3 jumper. Now, if you're down in the deep south and your loop does not reach those temperatures and you got just water in there, even though it's a closed loop system, we never cut the jumper unless, again, we got 15 degrees freeze protection in that loop. So again, good question. Thank you, Britt.